Hello, Godanius. In this video, I'll show you how to use the Godot state charts library to add state charts to your game. State charts are an improved variant of state machines, and they can help you to implement complex behavior with a lot less code. This is an intermediate level tutorial, so you should know at least the basic building blocks of the Godot engine, like nodes, signals, and GDScript, to take the most value out of this. Okay, so now we're in Godot. The first thing we need to do is to install the extension. And we can do that by going to the asset library, searching for state charts. There we go. We just click on download. From here you can decide if you want to have the examples with it. If you don't want any examples, then you just uncheck them and you only get the add-on. We don't need the examples right now for this tutorial, so I will just install the add-on. Okay, so that's it. And after you have installed this add-on, you need to activate it in the project settings. So you go to project settings, plugins, and you click the enable button next to the Godot state charts, and that's it. So now it's active and we can use it. So what I had in mind was some scene where you have a watchman, and this watchman watches for an enemy and then reacts to this enemy. So let's quickly set this up first. So we have a 2D scene here now. We start by creating a watchman. So this will be just a node 2D. This will be the root of our things. So we call it watchman. Okay, that's nice. So it has some kind of icon. I just use the Godot icon and I put it down here so we see, okay, that's just the icon for it. Of course, we want to move this to the center, and then we can move the whole thing like in the middle here. For this watchman to be able to detect the enemy, we will also need an area. So we use an area 2D here. We add a collision shape. And we are just going to take a circle and maybe make this a bit bigger. Okay, so this is roughly what our watchman can see. Okay, so we save this. We call this maybe example. Okay. And now we are going to build the enemy, which will be basically the same thing. So we can just duplicate this and we call this enemy. Maybe we move it out here a bit, scale this a bit down so it's a bit smaller and we can see it a bit better. So let's try that. That looks nice. And we also going to make the circle a bit smaller. Since I duplicated this, I need to make the circle unique, otherwise they share the same area. It's not good. So yeah, now we have our enemy, which is a bit smaller. Okay, that is nice. What we want to do next is that the enemy should be able to follow our mouse. So it's just for demonstration purposes. In a real game, you would probably have some AI here, but we don't have time for this. So I'm just going to attach a script here. I call this enemy, and we are going to just really simple make this follow our mouse. So we should say global position equals get viewport, or actually we have a get global mouse position, so we can just use that. So let's quickly try it out. Yeah, that works out just fine. It follows our mouse. The enemy is pretty much done here. Okay, so now we can go back to the watchman. The watchman should react when the enemy enters this area. So now we're going to add the state chart to implement our logic for this watchman. So we select the watchman here, we add a new node, and we call it state chart, and you see there's the state chart. Okay, so we add it here. Now you can already see we have some area here where we can add states to our state chart. And you also see a little warning here that the state chart must have exactly one child. This tells you, okay, we need to have one state that is the root of the state chart. For now, we will just use this one, which is a compound state, to implement our first bit of logic. So I click on the compound state, and since this is the root state, I'm just going to call it root. Our watchman should be able to react when the enemy is going inside this area and when it leaves this area. For starters, we start with two states. We name one idle, which is when the enemy is outside, and we take a second one, which we call observing, which is when the enemy is inside. You again see that we have here a little warning, and that tells us the initial state could not be resolved. Is the path correct? So we click on this node, and we can see that there's a setting up here, which is called initial state. We have now two states below the root state, and the state chart needs to know which one is the initial one. So we assign idle as the initial one. Okay, now the warning goes away and everyone is happy. Okay, so next we need to detect that our enemy has actually entered. So we're going to use the area to detect this. And the area, it has a signal called area entered, and we use that. So first we add a script to our watchman. We call it maybe just watchman. Okay, delete all this, we don't need that. Now we can go to the area, use the area entered signal, and connect this to our watchman script on area entered. Okay, now we can detect that the enemy comes in, and now we need to do something with it. So when the enemy enters the area, we want to switch from this idle state to the observing state. How do we do this with state charts? Whenever you want to switch a state, you use a so-called transition. We add a transition below the idle state, and we give this a nice name. So we call it maybe to observing. So we know what this transition is doing. And now we can have a look on the right side and see what we can set up here. You see there's a to setting, which allows us to tell the state chart to which state we want to go. So we say, okay, we want to go to observing. There's another setting, which is the event. So state charts, they react on events. You put in an event into the state chart, and then all the transitions that currently exist, they look if they are reacting to this event, and if they do, they transition. So maybe we create a new event and we say it's enemy entered. When we send the event enemy entered, we want to go to the observing state. So how do we send events to a state chart then? Well, it's pretty easy. So we go to our script, we say state chart, send event, and we call this enemy entered. How do we see that it actually worked? Because right now, well, we sent this event, it probably will switch, but we cannot really see it. And for that, the state chart asset contains another thing called the state chart debugger, which we can add to any scene and we can use to debug the state chart while we are developing it. We can click this little one here, and you see there's a state chart debugger, and we add that. Of course, we don't want to have it below the state chart itself, but maybe rather here. Then we can resize it and maybe move it here to the right so we can see what happens. We also need to tell the state chart debugger which state chart it should watch. So we have an initial node to watch. We look here and we select the state chart. And now the state chart debugger will basically tell us the state of the state chart in-game, which is really nice to have. Okay, so you see we start in the idle state, and yeah, I just moved my mouse and we went into the observing state. It may actually be easier to see if we enable the collision shapes. So when we play, we can also see the collision shapes. So see, right now we are idle, and if I move inside, yeah, see we are going to the observing state. Okay, that was that. Now we want to, of course, to go back when we leave. So how do we do that? Well, it's very similar. Again, we use the area to detect when the enemy exits. So we use the connect again, go to our watchman on area exited, and we do a similar thing. We say state chart send event enemy exited. And of course, we need to have a transition here. So on the observing state, we have a transition to idle. We want to go to the idle state on the event enemy exited. Okay. We can quickly try this out again. So you see right now we are in idle state. We go in, we are observing, we go out, we are back to idle. So that's very, very easy. Now we can switch states, but yeah, just switching states is not really that useful. So ideally, our watchman should do something useful while it is in the observing state. For example, it could look at the enemy, right? It could rotate to look at the enemy. How would we do that? In the state charts library, all of the states have a lot of signals that you can use to drive your logic. For example, we are in the observing state and we want to run logic only while we are in the observing state. We can use this state processing signal and connect this to some function which will then only be run repeatedly every frame while we are in this observing state. So do a connect, add to the watchman on observing state processing. That is just fine. Now we can do something. So we can now, for example, say look at. Okay, we need to look at the enemy. Right now, we do not know what the enemy is. So when the enemy enters our area, we should probably make a variable and save the enemy. Okay, so we say var enemy. We initialize this with null. And when the enemy enters, then we just say enemy is area get parent. Right, so it's this area and then the parent, which will give us the enemy node. Now we can actually look at the enemy's global position while we are in this state. Let's try it out. Yeah, it's rotating. It's not exactly rotating correctly, but that is because Godot, when you do look at, it uses the right vector to look at it. So we can quickly fix that by rearranging our stuff a bit. We can rotate this icon to look to the right. And we can then rotate our transform back to -90. Now it should work. Yeah, that is much better. So while we are there, it looks at the enemy. That is good. What we would like to do next is that the watchman should go back into its initial position once the enemy leaves. That would be nice. So how do we do that? We actually want to run code when we go back into the idle state. And there's also a signal for that. So we can use this state entered signal here, and we can connect this to our watchman on idle state entered. In this case, we want to set our rotation back to -90. So we say rotation degrees is -90 as it was. And we can also set the enemy back to null because we don't need it anymore. Okay, so let's try again. If that works. Yeah, that looks good. And now we leave. Yeah, that is very nice. So how about we say our watchman is a bit vigilant and they do not immediately stop looking at the enemy when they are leaving this area. But they should rather like follow the enemy just a tiny bit, maybe a few seconds before they go back to their normal state. We can do this by making this transition delayed. So every transition can wait a bit until it kicks in. Right now it has a 0 delay, and the 0 delay just says, okay, do the transition immediately. So what we can do is we can maybe say we put a 3-second delay in here, and then we try again. And now once we leave, you see it will still look at the enemy for 3 seconds. And you can also see in the debugger that there's a countdown. Okay, so now maybe we want to have the watchman get into some angry mode when they see the enemy entering this inner area too often. So maybe it goes into some berserk mode and does some special thing. The thing is that with a normal state machine, you would now get into this territory where you would need to have a combination of states. It could be idle and in berserk mode, and it could be observing and in berserk mode. And the more states you add, the more complicated it becomes. But with state charts, you can actually use parallel states to solve this problem rather neatly. And I'm going to show you how this could be done. So what we're going to do is we're going to rename this state, and maybe we call this alert state. Probably not a good name, but yeah, we have to make do with this. And now what we can do, we add a parallel state. And we make this parallel state the root state. So this is the root state. And a parallel state activates all its child states automatically when it starts. And since it is the root state, it will automatically activate this alert state. And this will in turn activate the idle state. Now we want to add a new compound state for modeling this berserk mode. So maybe we call this berserk mode. It has two states. It could be either like normal, or it could be berserk. And we start out in normal state. So again, we just pick the initial state, which is the normal state. If we start it right now, you can see, okay, we start in normal mode, and the rest of the program still works. There's no change to that. We want to go from normal to berserk whenever the enemy enters for 3 times in a row. So we add a transition. We call it to berserk. We want, of course, to have the event be enemy entered, same as with the alert state. Right, so we also had enemy entered here, but we don't want to have it on every enemy entered. We only want it if the enemy has entered for the 3rd time. How would we do that? Well, we need, of course, some code that counts how often the enemy enters. So we say enemy enter count, maybe like that. Whenever we enter, we increase this by 1. Now we want to use this data in our state chart, and we can do so by setting a so-called expression property, which we can then use in our transitions to only run transitions when a certain expression is true. I'm going to show this really quick. So we say state chart, set expression property, and we call this enemy entered count, and we want to set it to enemy entered count. Okay. Now what this does, it allows us now to use this enemy entered count inside of this transition in a so-called guard. A guard is a check that happens when the transition is about to run, and it tells the system, should this transition run or should it not run? So what we do is we use an expression guard. Now we can write an expression here. So we say, okay, we want the enemy entered count to be greater than 2. Let's check if that works. So we enter once, and you can see that now the enemy entered count has been set, and we are still in normal mode, not in berserk mode. And we enter again. Entered count is 2 now. And we enter a third time. And now we are in berserk mode, because now the expression was true and the guard let the transition happen. So we are now in berserk mode. It would be nice if we could somehow see that we're now in berserk mode other than just in the debugger. So we are going to run some code when we enter berserk mode. So we say state entered on the berserk state, go to our watchman, say on berserk state entered, and then maybe we just make the icon red, right? So we can say icon modulate is colors red. So we can try this again. 1, 2, 3, and you see it's getting red. Now we want to stay in the berserk mode for maybe a few seconds and then return back to normal mode. And we already know how to do that. So we can basically just copy this transition, copy, paste, and we call it to normal. Of course, it's always good to rename your stuff, and we go back to normal mode. Maybe, yeah, we could also run a delay of 3. However, we do not want to wait for the enemy to exit. We run to normal mode no matter what. And this is a new thing. You don't need to write an event here. If you don't write an event, this transition will immediately run once the state is entered. So the state is entered, and immediately this transition will go back to normal mode, but it will wait for 3 seconds. So we can try this out again. 1, 2, 3. And you can see the berserk is counting down, and now it's going back to normal mode. And ideally, we would, of course, want to remove this red color. So what we're going to do is, when we enter this normal mode, is again state entered on the normal mode, and we remove the red color. So we just say icon modulate equals color white. And what we can also do is we can reset our enemy enter count. So we can say enemy enter count is back to 0. And we also need to set it in the state chart. So I'm just going to copy this here. So state chart also knows about it. Okay, so let's try it out. 1, 2, 3. And it gets white again. So you can see how using the parallel states really simplifies all of this code. The new code that we have added for the berserk mode does not have any influence on the existing code that we already have, and the existing code just continues to work because these states basically are independent of each other. This has been only a small overview on how you can use the state charts library. If you would like to try it out for yourself, please check the links in the description. You can start by having a look at the examples that come with the library, the ones that we didn't install at the start of this video. These examples contain some more complex state charts, so they're a nice step up from what we have covered here. There's also a manual which explains all the features of the library and has also some helpful tips for designing your own state charts. If you like this video, then give it a thumbs up, and if you want to see more videos like it, then subscribe to the channel and get notified when new videos are available. Until next time, happy codeineering!